All right, so video 2 here is going to focus on the angle measures in our parallelograms. Okay, so it says, how are consecutive angles in a parallelogram related? Well, let's go back to this idea, right, of what a parallelogram is. We should know that opposite sides are parallel, AB and CD, BC and AD. So if you think of AB and CD as the parallel lines, and I extend them, and let's let BC be a transversal, right? Then how does this angle and this angle compare? Well, they're in between the parallel lines, both below the transversal. These two angles are same side interior angles. And if the lines are parallel, same side interior angles are supplementary. So since you have parallel lines, since the lines are parallel, make it grammatically make sense. Since the lines are parallel, same side interior angles are supplementary. So in this picture, right, we have 4 pairs of consecutive angles. So angle B and angle C are 1. So the measure of angle B plus measure of angle C is 180. And we just keep going around the horn, right? So B and C. So then C and D are also. So measure of angle C plus measure of angle D is 180. The measure of angle D plus measure of angle A is 180. And the measure of angle A plus the measure of angle B is also 180, right? So your consecutive angles are supplementary. Supplementary. Now the question is, how are the opposite angles in a parallelogram related? Well, the opposite angles would be like angle A and angle C, right? Or angle B and angle D. Okay, so there's only 2 pairs. Well, let's take a look at angle A, right? Okay. Angle A, okay, is supplementary to B, okay, and supplementary to D. Angle B is supplementary to A and supplementary to C. So we talked about a theorem, and I'm actually going to focus on angle B. We focused on a theorem way back, topic 1, that if an angle is supplementary to 2 angles or 2 congruent angles, then the 2 angles that it's supplementary to must be the same. Let me rephrase that. If 2 angles are supplementary to the same angle, then those 2 angles are congruent. That's how it should have been stated. I apologize. So in this case, angle C is supplementary to angle B, and angle A is supplementary to angle B, as talked about up here, right? Angle A and B, angle C and B, right? So because of that, since angle A and angle C are both supplementary to angle B by the congruent supplements theorem, angle A is congruent to angle C. So angle A and angle C are congruent. By the same reasoning, we could understand that angle B would also be congruent to angle D. So in this case, your opposite angles are congruent. So here are the angle relationships. I'm going to use blue to show the congruence again. Angle A and angle C, angle B and angle D. Consecutive angles supplementary, opposite angles congruent. And again, if we go back to the very beginning in topic 2, I talked about acute and obtuse, right? If you look at angles A and B, angle A is acute, angle B is obtuse. Probably going to be supplementary. If I look down here, angle A is acute, angle B is obtuse. They're not going to be congruent. But angle A and angle C are both acute. They're probably going to be congruent, right? It's a parallelogram. It's a pretty nice picture. Very good. So here's your official theorem for the consecutive angles. In a quadrilateral as a parallelogram, the consecutive angles are supplementary. And again, because those opposite sides are parallel, you do have these supplementary relationships. So you'll see here that you have 60s and 20s, right? 60 plus 20 is 180. Let's use the tool, go on to Solve and take a look-see. Let's change some things around and see what we get. Right, so let's move what? I can move C around. So notice I kind of changed the angle of the parallelogram, but still 39, 39, 141, 141, 39, and 141 is 180. Okay, the formal answer for the opposite angles. So here we go. If the lines are parallel, opposite angles in a quadrilateral are going to be, or in a parallelogram, are going to be congruent, right? So here's the main idea. And again, we'll go to our picture. And again, we can change how the parallelogram is slanted, however we want to. So there's a changing B. So there we go, 55, 55, 125, 125. Acute, acute, obtuse, obtuse, right? Should make sense. Okay, so I have one kind of algebra problem here. So it says the green shape in the fabric design is a parallelogram. The measure of angle 2 is twice the measure of angle 1. What are the measures of angles 1, 2, and 3? So this is a parallelogram, right? So this guy right here is a parallelogram. So it says the measure of angle 2 is twice the measure of angle 1. So if we let the measure of angle 1 equal x, then the measure of angle 2 is 2x. So angle 1 is x, angle 2 is 2x. And because we have a parallelogram, we should know that the opposite angles are congruent. So this is a 2x and this is an x. We also should know that the consecutive angles are supplementary. So let's use angle 1 and angle 2 and the fact that they're supplementary. So in this case, because it's a parallelogram, consecutive angles are supplementary. So we should know that the measure of angle 1 plus the measure of angle 2 is 180. We should know that x plus 2x through substitution is 180. This is a 1x and a 2x. That's 3x equals 180. Divide by 3, and x is 60. So if we just plug it in, right? The measure of angle 1 is going to be 60. The measure of angle 2 is going to be 2 times 60, which is 120 degrees. And that's also going to be the measure of angle 3, because it's opposite with angle 2. So angle 1 is 60, angle 2 is 120, and angle 3 is 120. And there you go. Done. All right, I'm going to stop this video. I have one more video left covering the diagonals of a parallelogram. All right, stay tuned.